Hello students, in this video we are going to see about IPv6 addressing abbreviation and type of IPv6 addressing. As you know, in the last video we have seen the IPv6 addressing, what is the motivation of IPv6 addressing, what are the special features you are having in IPv6 addressing, and what are the advantages of IPv6 addressing over IPv4. So what is the first thing you have noted in IPv6? The length of the IPv6 address is increased to 128 bits, whereas the length of IPv4 address is 32 bits. 32 bit for IPv4, and this is for IPv6. Okay. So by how many factors we have increased the address space? It is 2 power 96. 2 power 96 more IP addresses we have added in IPv6 than IPv4. Okay. Then how we are representing the IPv6 address? The entire 128 bits can be the binary bits, but we are not using the binary notation. We are using the hexadecimal notation for representing the IPv6 address. We are using the hexadecimal notation. Okay. So whether you have seen any IPv4 address using hexadecimal notation? No. And the IP addresses, either as a binary number, it will be represented as a consecutive sequence of 32 bits, but even that we are using the decimal notation. Like let us take IPv4 address. Sort of new screen. So let me take this IPv4 and how it is differing with IPv6. Let me take an IPv4 address 192.168. 192.168.10.1. I think you'll be familiar with this address when you're doing the lab program. So IPv4 address is divided into 4 sections. Is divided into 4 sections. At the same time, let us look at an IPv6 address. I'm writing an IPv6 address FCDE. Okay, so this is the representation of IPv6 address in hexadecimal number. You just think the complexity of representing it as a sequence of 128 bits. Even the hexadecimal number we are struggling to write. If it is a 128 bit length binary address, it will be very hard. So we are using the hexadecimal notation. And here you can see in IPv4 we have divided the IP address into 4 sections. In the case of IPv6 we have divided into 8 sections. So there are 4 sections. Here we have divided into 8 sections. Okay. So this section 1, 2, 3, 4, 5, 6, 7, 8. So totally we are having 8 sections. Then in IPv4, each of the section is an octet. Here each of the section, like if I am taking this section FCDE or AA19, it is an hextet. So in the octa 8, remember. So each section is 8 bits. Hexa means 16. So each section is 16 bits. So here how many sections are having? 1, 2, 3, 4. So each section is 8 bit. And how many sections? 4 sections. So equal to 32 bit. So here this 8 is length. And this 4 is number of sections. Similarly, we can do the length of the section is 16 cross. How many sections are having? 8 equal to 128 bits. And value in each sections. In IPv4, the value of each section ranges between 0 and 255. Whereas in IPv6, each section the value will be 000 and F. So it can be any value between this range 0000 to FFFF. Whereas in IPv4, we know it may be 0, maximum it can be 255. So like this, you just remember the difference between IPv4 and v6. Summarizing 32-bit, 128-bit. Then here we are having 4 sections. Here we are having 8 sections. And here each section is called octet since it is having 8 bits in IPv6. In the case of IPv4, it is called as octet. In the case of IPv6, each section is a hextet. That means it is having 16 bit. Then the value in each section ranges between 0 and 255 in IPv4, whereas the value in IPv6 ranges between 000 and FFFF. So address wise, section wise, these are the difference between IPv4 and v6. Furthermore, we are having a concept called abbreviation in IPv6. So let me take the IP. So this is the original IPv6 address for of a particular interface. So instead of writing this, somewhat we can abbreviate this as FCDE. colon AA19, and here we are having continuous zeros. So instead of writing 0, so what we can do, we can use double colon. We can use double colon, and we can start with A, B, F. C, D, A, B, F, 2109, and A, B, C, D. So here the double colon, the system will understand all the values in between this double colon or all are zeros. So it knows the length of IPv6 address is 128 bit. So automatically this section will be taken as 0. So there's a one kind of abbreviation. Let's go for the another case. I take the same IPv6 address FCDE, the same IP address, and EA19 and 731 7312. It takes another number. Okay. So here how we can abbreviate FCDE and EA19. So here we can use double colon. Double colon will be sufficient. We can write EA, and here since already we have used double colon, here we can make it as single zero, because the four zeros value wise it is equal to single zero, 0, then 2109 AB CD. Okay. So like this we can cut short the value. Suppose here if you are having the value instead of this A, if you are having 0, 0A19. When you want to cut short, abbreviate, you can leave that 0. A more precise way we can represent. So here we are having 0. Here too we can leave it. So when you are having preceding 0, we can leave it. When you are having 0 after the number, suppose after this F, if you are having 0, we should not leave that, because that will change the value. Only the preceding zeros can be avoided. And this 2 colon format should be used only once. Only once, 2 times we should not use. For example, you can see here FCDE 0000 then some number A, B, C, D. A129. Okay. As per the last example, we can replace this with double colon. F C D E double colon. Then A B C D double colon. A1 to 9. Then 1 2 3 4. But this is not allowed in IPv6 abbreviation. Either we can use double colon here or only here. At two times we should not use. So this can be written as FCDE double colon ABCD. For this all four zeros we can make 10 because value wise it is same. Again for this 4010, then it can be A1 to 9, then 1 2 3 4. This is right. Otherwise FCDE 0 0 ABCD. Here we can use double colon. Then we can write A1 2 9 2 3 4. Either in this way you can write abbreviation or in this way you can write the abbreviation. So this rule is called zero suppression. This rule is called zero suppression in IPv6. Okay, so we have seen the difference between IPv4 in address representation. So these are the prominent differences in address representation, and we have seen abbreviation concept in IPv6 addressing. Okay. Now we should know what are the categories of addresses. What are the categories of addresses? The first one is unicast. Next one is anycast. Third one is multicast. So unicast defines only one interface. A packet can be delivered to only one interface. Interface in the sense computer or router, like one-to-one communication. Only one interface. And anycast represents a group of computers, with a common prefix. But if you are having 10 computers, 10 computers are having the common prefix, to only one member of the group, the data will be delivered. Okay? Data delivered to only one member of a group, not all the members of the group. Okay. This will understand going further. Addressing in D. Multicasting, obviously the same meaning, multicasting. It represents a group of system and the data will be delivered to all the members of the group. All the members of the group. This is called multicasting. Suppose if you are having 10 members in a group, if all the 10 members are receiving the data, it comes under multicasting. Then you are having 10 members in the group, but only one member will be getting the data, that comes under anycasting. And unicasting, it does not aim the group. The target is only one system. To the one destination, the data is forwarded. So these are the broad categories of IPv6 addresses. The next video we can see how we are representing a unicast address. Some more about the prefix, suffix, and how we are dividing the address into the different fields.